Just a sec.
Right. I'm watching if we
Hello?
can see us.
Hello?
Hello, everyone. We are today to the next session of this great Java Champion Conference. With us is Mohamed Aman, that we are going to start his session at this time. So I leave Mohamed, and let's chat if you have any questions on the YouTube chat, and we are going to answer the questions at the end of the session. So we are going to start, and let's go with Mohamed.
Sorry for this. Let me switch back to my presentation. Can you see my presentation? Supposed to, yes. Thank you, Roberto, for the introduction. Welcome, everyone. I hope you enjoyed your rest of the session of the day. You attended some great sessions for great speakers previous to mine. And also there is more sessions coming, and also tomorrow and after tomorrow we are 4-day conference. So I'm happy and glad to be here talking about the hidden gems of Java 19. And as you know, we have these traditions to speak about this kind of stuff. It's here I'm not going to highlight only Java enhancement proposal features, but always there is some hidden features coming to the GDK that we need to know about it in terms of many perspective. There is tools introduced, there is some APIs introduced, some enhancements, some bugs fixing, also as well as deprecation and removal, which we need to know about them. So my name is Mohamed Aman. I'm working as a solutions architect for a company called Nortel. I'm doing consultancy also and trainings. I'm Java champion, and this is my luck to be here in the Java Champion Conference. So I usually do publication in Java Magazine. And by the way, there is two parts of this talk on Java Magazine. There is the links for both of them. I will share the presentation, and everything on this presentation are linked, so you can go to watch and read full package about all of these kind of enhancement and features. Here in this session, I'm going to speak about the most important things that we really need to focus on. So you can also have, at any time, you can catch me and you contact me. So, or you just Google my name and you will find everything about me. Most important that all the projects, updated projects to the latest GDK, you will find it on my GitHub account, and also you can contact with me in LinkedIn. You can ask whatever you want. So our agenda for today is divided into 6 sections. So first we will have introduction about Java 19 and how it goes. And then we will check about the features in Project Ember, and the features came into Project Loom finally to Java 19, which is the most interesting part of this GDK, and also Project Panama and what it's brought for us included to be included in GDK 19. And finally, definitely we have to see what's new as improved APIs and some other new cool stuff. And finally, because we are migrating and we have to take care of, the APIs that has been marked for removal and also has been deprecated. So first, small introduction about Java history. You know that we are running fast. So Java 19 is considered release feature. It's not LTS. We have 3 LTS until now, which is GDK 8, as you can see here. And then we have Java GDK 11, the second LTS. and then Java 17 LTS, which is the current LTS. Then we will have Java 21 will be the next LTS in September. So just give me 1 second, please. Excuse me. Sorry, there is some people knocking the door. I don't know who they are, but it usually happens. So coming back to our topic about Java, so the next LTS, as I have said, like it's 21, it will come next September this year. So this is how it is. You can compare the features that we have here. And as you can see, after Java 9, actually, we delivered like 91 feature, but currently, because it's 6 months release, so we are focusing more in the enhancement on the of the JDK introduction for the features. Either it's incubator, preview features, or finalize. So Java 19 is just 7 features, and we are going to talk about them. So let's go to check out the Project Amber and what Project Amber brought to us in JDK 19. So first, we have pattern matching for switch, and this is already has been, it went through a couple of preview rounds, which the first preview, it was JDK 17, tuned preview, as you can see, JDK 18, and third preview in JDK 19, because there is a lot of enhancement that happens to this. And this feature, as I told you, in Java 17, we always write something like this, and especially when we would like to make sure that we have a case, and this case has also properties. It's like I'm checking some string, and this string has a length greater than 8, then I would like to do something in that case. So this is really the previously valid compatible code for Java 17 and 18 as well, but we changed this in Java 19 for more readability. So instead of having string and checking the length, now we dropped and as a Boolean operator and introduced when. So you will have it written like this. And also what is nice about when, it's a contextual keyword. What does it mean, contextual keyword? It means if you have any code written like methods, variable, or something, it doesn't break, because when is just only valid in the context of the case statement, so or case label. So this is an enhancement we have. It has been done, brought to you by JIP 427. And then let's talk about record pattern. Record pattern is first introduced as a first preview in JDK 19, and record and type pattern can be nested also to allow robust declarative and modular data processing. And assume that we will have this record point, and previously, if you would like to process or to check about something inside the record, we do this kind of check first. So object instance of point, which is point is the record point, then I have to use the casting variable to point to X and Y, while we can infer all of this, introduce a pattern to make it easy for you to use and for us and for more readability. So this is very valid since Java 16 as a pattern matching for instance of, and then as of Java 19, JIP 405, it allows us to use the new feature called record pattern. So now we can use it like this. Object is instance of point, and you give the full pattern. And in this case, you can directly access X and Y without requiring the casting variable in this case. So it's more readable and not verbose anymore. So as their access. And also we can have pattern matching indeed, because we enhanced the switch statement and expression to take care of the patterns. So we also introduced this in switch statements. So previously it was like this case point, then I have point to access internal variables or final variables, and now final fields, I mean, and now we can rewrite it like this. It's case point, and you directly give the full pattern, and you can access the final fields inside it. As you can see, it's more readable and more maintainable. So, okay, we continue also. What if we have something called like nested record pattern? What we can do with this? Something like this. Imagine that we have a line, and this line is composed of 2 points. And now I would like to check about this. So, we can do it like this. I have a print method, and we can use record pattern to print all the paths X and Y coordinate easily in this way using record patterns. And even for nested like this, if it will be line of points, which is the 2 coordinates of the line, and even for each point we can access its X and Y, and finally you can print the result like this. You don't have to declare line as a variable, then you say line.point.x and then line.point2.y and all of this kind of stuff. You just introduce the pattern and you have full access to the internal fields. Nice thing also, indeed, if we introduced it to instanceof, we are also possible to use it with switch statements. So you can expect definitely that the case label can handle this kind of nested record pattern as the following. And the record pattern provide an elegant way, as I told you, to access records elements after type check. And you have it and you can print it. So this is what Project Amber brought to us in Java 19. And this was like the most important features that we have right now. Now let's move on to Project Loom. Loom actually is it was there for long time, and Project Loom actually designed to deliver a new GVM feature and API to support easy to use, high throughput, lightweight concurrency, as well as the new programming model, which is called structured concurrency. So Project Loom finally brought to us the long-waiting feature for JDK 19, which is virtual threads and structured concurrency. But virtual threads, it's actually, we will talk about it. It's introduced as a first preview in JDK 19. You can imagine that it's not Incubator, it's just a preview because it was almost finalized. But there is some little bit enhancement because there were a lot of work has been done to bring virtual threads into the system, and this is a game changer, feature that will change the way that we are writing threads and also servers, tools, even. And you will see some examples how we can enhance our current project written in reactive programming, which is a little bit complex from my point of view to understand and to write and to maintain the code of reactive programming. So, and there is also a big difference when it comes to throughput because virtual threads are not equal one-to-one to the operating system threads. It's actually, it's the goal here, it's a subroutine inside the one or more threads. So, for example, if you require a task, if a request takes like 2 seconds and the thread pool is limited to 100 threads, for example, and the application could serve up to 50 requests per second. Even if there is several threads are served per CPU core, the CPU would be underutilized because it would spend most of the time waiting for the responses from external services. So you really need thousands of threads or maybe 10 of thousands. However, you are not going to get that from your hardware. You will never. What we can do is just scaling up the services. So there is a solution. What the previous solution, before I'm telling you about the solution to solve this problem of the threading and how we can overcome this problem, I would like to tell you the goals of this proposal is to enable the server applications really written in simple thread per request type. Do you remember? This is all the style that we are used to scale with near optimal hardware utilization. You don't need a lot of CPU cores because you're not utilizing operating system threads. Second, we would like to enable existing code that uses Java.lang.thread API to adopt virtual threads, actually, with minimal changes. So we don't need you to migrate your code to new threads with a few changes, which is like neglectable, we can say. You can just adapt quickly to virtual thread. And also it's easy to troubleshoot, very important, debugging, which was very hard using reactive programming, and profiling of the virtual thread with existing tools inside the GDK. And there is no attention, by the way, to remove the traditional thread implementation. It will be out there because it's used, or silently even migrate existing application to use virtual thread. You can still continue using your normal thread implementation, and you can migrate later if you want to use the virtual threads. And finally, no intention to change the basic Java concurrency module. So this is the goal of this Java enhancement proposal. But let's get back to the problem I have described, because I need to scale my services. My hardware doesn't utilize exactly for the number of requests that I need. So we can do this with reactive programming. Something like this. Imagine that I need to, my service here would like to create an order. And here I'm using reactive programming module. So you are familiar with Reactor project or rx.java. So like, you know, there is a lot of problems here, despite how the code is laid out and how we are waiting to get the resources from session server, then enhance and enrich, create order request, and then, you know, you do some other persistent service to persist the order, and you are waiting the confirmation from all of those to finally subscribe and get back the result for the customer. So actually all of this from line number 6 until line number before subscribe, which is subscribe on 20, line number 20, it's just describing the way how the data should be processed until subscribe. After the call for subscribe, the actual request has happened. So you cannot debug in the middle of the reactive here chain. You cannot debug because the call happened once you hit subscribe. So this is hard to maintain, not easy, you know, even to understand. And the other way is to use virtual thread will allow you to implement the reactive example quite simply as the following, for example. It's like, so you don't even, you know, we have a big problem when we are connecting database resources. They are not compliant with reactive or reactive programming model. So they have to create database drivers to work with that programming model. Now, no, you are just using the normal threads module implementation, and you just adapt it to virtual thread, which is part of the GDK and GVM. So in the new module, you can rewrite your previous code, which is in reactive, in this simple, because each component knows how to handle all the communication in its own. I can debug. It's a traditional normal programming model. So I can debug at line number 6. I can debug at line number 4. I can definitely debug in line number 12, and also to know where is the problems, and finally also debug at line number 15. So from debugging point perspective, it's more and more, you know, easier and enhanced. So this is all about like virtual threads. I will encourage you, if you would like to read more and know about it, go to my article about hidden gems of Java 19. I wrote a lot of you know, information about virtual threads with a lot of resources and examples, so you can be aware of all the details of that. So let's talk about structured concurrency. When we have a new model like virtual thread, definitely our work will be more organized. And structured concurrency, actually, this is the first incubator because it depends on the virtual thread. It introduced to the Java language, and since GDK 19, they are part of Project Loom, as I told you. So this is actually to simplify the multi-threaded programming by introducing this kind of programming style and model. So structured concurrency actually treat multiple of tasks. Many times I would like to invoke multiple parallel tasks and I need to have control over these tasks. I can cancel, or some error handling, improve, and observability, who does what, inside this. So if I go traditionally, I can do this with service executor and future API. There is no problem, but structured concurrency give us more control about this. Let's see the pros and cons of each module so you can understand it. So structured concurrency API, as you know, it's preview incubator API. And the goal in this proposal is to improve the maintainability and reliability and observability of multi-threaded code that we will have, and promote the style of the concurrent programming, which can eliminate common risks definitely arising from cancellation and shutdown of subtasks, such as thread leaks and cancellation delay. Means if one thread, let me give you an example. So consider the following example. You can use Java executable framework, as I told you, to write concurrent application like this. So I have a definition at line number 1 for executor service, and I have a new threads from the new cache thread pool, and I would like to create an invoice, and this invoice involves many tasks. First, I would like to get customer information from one service. I would like to get the order information from the database, and finally I will invoke the template, get template for some certain language from a file system. And after all of these kind of future tasks completed, I would like to get the result and finally generate the invoice based on this information. But there is some problems here. If one of these tasks raise a problem or like exception or something, and this is called leak, the other tasks will continue to finish. It will never say, hey, I have a problem, I cannot get the data at the customer service, so stop order service and stop invoke template service. No, they will continue, which is mean wasting resources and also wasting the thread that is running without any reason. So the problems here, as you have seen, you can pass these 3 subtasks to the executor and wait for partial result. Yeah, we can do it. And this is the current, but it's easy to implement definitely as the basic tasks quickly, but consider these problems. How can I cancel, other subtasks if error occur in one of the subtasks? How can I cancel a subtask if the invoice is no longer needed? How can I control this? And how can you handle the recovery from exception if one of them throw an exception, but the others still continue? I have no control over them. So all this possible issue can be addressed, but the solution would require a complex and difficult to maintain code using the current solution. And the solution here is to introduce structured concurrency. So the only change, as you can see here, by using structured task scope, which is the main class here to rewrite the previous code into structured concurrency. So you can see here that I'm using try catch. I have a scope, and then I create from structured task scope this scope, and then within this scope I submit and I fork for different virtual threads that I have, but I have control over. And then I say, hey, scope, please join all the forks for the result when they finish. And scope.throw if failed means if there is anything happen, please propagate the error and stop other threads. They are not, which is actually virtual threads, they are not required to complete because one of these tasks has been failed and the join cannot be completed. Then I will have an exception raised, like interrupted exception or execution exception, that will tell me this create invoice task does not complete successfully, and here is the error happening in which one of those invocations. So as you can see, we have control over everything that we have. If it goes successfully, the join happens, no errors, I can get the result, and then finally here all the forks, I can generate the invoice at the end. So structured concurrency gives us the ability to control all subtasks or unit of work from this perspective. Those are literally most significant part came to GDK 19, and I believe it will be big game changer in the way that we are writing threading and also how the application will take benefit through toward throughput, lightweight, and really like not so much scaling of the application. It will enhance the cloud computing also as well. So this is something really I was looking for, and I'm excited to use it, and I hope you are excited to try it out. And by the way, in JDK 20, we didn't have a lot of changes in virtual threads. It just reproposed as a second preview for feedback. So I assume in 21 it will be finalized. And concurrency, we introduced structured concurrency. We introduced scoped values classes to replace the old thread local class, which were error prone, to make this kind of shareability between these subtasks. So this is like future information about the JDK 20, and I have written an article about this. It will be published soon in Java Magazine. So have a look about, it's a sneak peek about what is coming in Java 20. So I think this is everything about Project Loom and what Project Loom brought to us in JDK 19. Let's move on to the other project, Project Panama. Project Panama is one of the greatest projects to bring us like vector mass, and also it's responsible about how we can talk to other languages like C++ and enhance the Java off-heap memory and allocating big memory, and also contacting to different language like C and C++, replacement for the old GNI. So foreign function and foreign memory brought by this project is very important, and it has first incubation at JDK 17, tuned incubation in JDK 18, and you can see in JDK 19 start the first stage of preview. And this is very important. It means that we reach it to the point that we are mature enough to use this API. It's much easier to use than the old native Java native interface and the error-prone security leaks and hard to maintain code, actually. So this is a complete replacement for the old technology Java native interface that has been in works for a long time. So as I can see, foreign function memory API, FFMA, enables access to native memory that is memory outside of your Java heap. This is very great tool for tools that need to deal with big memory, reading large files. I think Spark also has this idea of reading off-heap big bunch of data, then processing it, then use it. This will allow your services not to require a lot of memory when you start up, because you need to read a bunch of data. You can read it outside, process it, and then the normal functionality for your application will work without any problem. You didn't need a larger scale, and because you just need it for some certain purpose or time. It's not the core function of your application to process always very large data. You need it sometimes, so this is really good for that. Need a faster access to some native library, you can use foreign function memory API. So in Java 19, this has been promoted, as I told you, to preview stage, means it's completely toward finalization. So it's introduced in this JDK 19, the main goal is to introduce a new API for easy access and handle memory segment and function calls. So it was a little bit complicated before, but we enhanced it. Let's see some code. And don't forget that when you would like to run this code, you have to enable, because it's a preview feature, you have to call -- enable preview flag with your Java compiler and Java interpreter. So this is what's a JVM. This is very important in order to such coming code to work. So imagine that I would like to call a C++ function that stores string of the heap memory, and then I call the function, I pass happy Java champion conference, and I would like to know from that function what is the length of this string. So as you can see here, I will get a lookup object for commonly used libraries, and then I will get handle on the str, which is string length method function in the C standard library. and this is how I get it as a native linker. I get the function. If there is no function called like this, it's through exception engine, then please, I would like to handle it's a Java long as a return, and there is the address of the memory. And then I would like to convert Java string to C string and store it in the off heap memory by using memory segments. And this is how I locate it as a UTF-8 string. And finally, I would like to invoke dynamically and that method on C++, giving the string and then say, hey, return for me the lens. And finally, I can print the lens at line number 18. So you will get the lens. So this is how I can use foreign function and memory API for this probability. This kind of calling native APIs, especially C and C++. It's much easier here, easy to handle and easy to maintain. No security problems, and now it's more secure and robust. Vector API, this is the fourth incubator, because Vector API taking advantage of all the enhancement has been done to the GVM. So it's first introduced as an incubator in JDK 16, Tuned Incubator 17, third 18, and we are still Incubator API, as you can see in JDK 19. It takes some enhancement from the foreign function and memory to introduce some enhancement to the Vector API. And this is the goal of this proposal here, which was we have a new user model in the API. Developers now can use this hotspot GVM auto-vectorization to design sophisticated vector algorithms in Java that are more reliable and predictable. Sometimes there is a big confusion about this kind of vector API, like why? Someone asked me one time in my session, like, why you are focusing too much on the collections vector class? Why it needs all of this? Like, oh, you are mixing between vector API as a vector mathematics and computation and the collection vector, which is already going to be deprecated. So it has nothing to do with the vector class, like array list in the collection API. So there is a big difference, and sometimes people confused. So this is something that I would like to announce and share with you. So the second is that the foreign function and memory API preview defines improvements to loading and storing vectors to and from memory segments as a part of the API proposed for JDK 19, this API that we spoke about previously. And also, it takes advantage that introduce complementing, the vector mask compress operation. Java 19 adds the cross-lane vector operations of compress and expand. So these were the most important enhancement happened in JDK 19. This is what Project Banama brought to us. And if you'd like to know what is Project Banama for, again, it just, focus on interoperability between GVM and defined foreign non-Java APIs. This is the main focus. And this includes also interfaces that are used in C libraries. So let's now see what is the new language API and other stuff brought to the JDK, not just only Java enhancement proposal that we always speak about as a feature. There is a lot of enhancement, as I told you, like security enhancement, deprecations, removals, and we will see, and also additions and many, many more. Definitely, as Java always trying to catch all the operating systems and, all of the hardware types and the most popular open source operating system now, JIB 422 bring to us in JDK 19 Linux RISC-V port for this operating system. RISC-V is a free open source instruction set architecture, as you know, that become increasingly popular. And now there is a Linux JDK for that. For that architecture brought to us by, this JDK, lovely JDK 19. And a wide range of language toolchain already supports this hardware instruction set, so it's ready for production. This is why we have a port. Now, almost all JDK bringing different ports. We have for Mac, for normal x64-bit, we have for M1 machines port, we have for Windows Server, we have Linux RISC, we have for any hardware and operating system instruction set, you will find a port. This is bring Java everywhere and enhance the portability. So currently, this port will support only one general purpose 64-bit instruction set architecture with vector instructions also, and RV64GV configuration of the RISC-V. So more maybe be supported in the future, but this is the first support by this kind of port. And this is also support the subsystems that are introduced with supported by JDK 19, which is C1 client just-in-time JIT compiler, and also C2 server JIT compiler, template interpreter, and finally all mainline garbage collectors, including even ZGC garbage collector and Shenandoah, brought to us by Red Hat. So this is the new port that we have, something lovely. If you are working with this operating system, you can use this port. We have also, you know, in the way that we are enhancing in JDK 18, we introduced one new JIT called UTF by default, and this is literally changed the way that we do I/O, and we are enhancing all these kind of I/O operations. So it's always will deal with UTF-8. So you don't have to worry about writing file in Unix or Mac or Linux, which use UTF by default, and then you're trying to read this file using without, you know, you forget about the character set. On Windows, and Windows use different system, CP 1525, I think. So which different encoding, which will end up with you to have rubbish. So in order to fix this problem, enhance the portability, we make all, if you didn't set the character set that you want, it will use UTF-8 by default. So if you write something on Windows, it will be written by default to UTF-8, and then you can read it on Mac. If you write something on Mac, by default, it's UTF-8, and you come back to read it without setting the character set, it will be read as UTF-8. So you have no problem for interpreting the output anymore, and you will not have rubbish. So enhancement, so if you are run an existing application with Java 19, you may see some question mark on the console instead of special characters. So this because of, as of Java 19, the operating system default encoding has been used to print on System.out and System.err console. So if that's not what you want, and you don't want to prefer to see the output in, and you would like to see the output in UTF-8, I advise you to add the following JVM options when calling your application. So you can use -d, using -d switch, and studio.out.encoding equal UTF-8, and -d studio.error, studio.error.encoding UTF-8 will solve the problem for you. But in the other way, if you'd like to set it globally, that will affect all your application, which is preferred, you can use this _Java_options, and you just give the previous encoding. It will be caught automatically by your application. And this is something new, and yes, it's underscore, start with underscore. So don't be confused. This is how the global environment variable should be called and will be picked. So we have a new methods to create pre-allocated hash maps, and this is very important because someone will ask me why we need such a stuff. And because hash map has a default load factor of 0.75 when it's initialized, this indicates that the hash map get rebuilt or rehashed with double the size as soon as it grows to 75%, it's filled. Thus, the new hash map is initialized with the capacity of 180, can hold only 100 139 elements. It's not as you expected. So you have to do here some math in order to solve this problem, which you don't have to do it, and it's confusing. So to create a hash map for exactly 180 mappings, you have to do this. You have to take 180 divided by the load factor, then you have to create a map with 240, which is confusing because anyone can read this code. It will say, okay, you are pre-allocating a hash map with 240 element, which is actually no, it's not the case because it will hold 180 element. So we introduced new static methods. For this example, it's a new hash map. So you can just do it like this and it will do the magic for you. So hashmap.new hashmap, and you just give it 180 element, it will pre-allocate for you 180 element as it should be. And also we have labor-saving static factory methods that has been created in Java 19 for most of the others maps like hash map, linked hash map, weak hash map, hash set, and linked hash set. All of them pre-loaded with the new static factory methods to do this kind of pre-allocation correctly. Some other enhancement that we have additional datetime formats. We always trying to enhance, but this time I give you the opportunity to not just use the predefined styles where available, like formatter style, the full date and time style, or long style, or medium style, or short. No, I can allow you definitely to use the new datetime formatter of localized pattern, and you give your predefined pattern on your own to give you more freedom. So for example, if I would like to print something like Feb 2022 in US local, or this kind of character in Japanese, I can do it easily like this. So I use datetime formatter of localized pattern, then I give the pattern of my choice, and it will be localized also and print the output based on the locale you are using or the operating system locale. So this is another enhancement. Additionally, we have this bug fix in Java 19. The process of concatenating string now evaluate each parameter and eagerly create a string from left to right, because this fixes a bug it has introduced in Java 9's JIP 280, which introduced string concatenation technique based on invoke dynamic. And what happens? For example, the following code now print zoo bar, not zoo bar. So previously, before Java 19, if you write string builder and you just use string builder zoo, and then you say, okay, print builder, because it has zoo, builder.append bar, it will be zoo bar. So this is not the required functionality and not expected behavior that we have. If you run this code on Java 19, this has been fixed, and now it will print zoo bar, which is, yes, as it's supposed to be. Because this will be appended, and then the evaluation will happen. Then this builder will have the variable, the value of this append zoo bar. Then the builder, which is now become zoo bar based on this invocation, and then the other one, it's already appending it, it will be zoo bar. So this is not the correct behavior, but now it has been fixed to make it correctly with the expected behavior. This is the most, not all the hidden gems actually in JDK 18. Yeah, we something like we support, we have now support also Unicode 14. And every JDK you will find in JDK 20, we support Unicode 15 and so on. There is a bunch of stuff I cannot speak about. I'm just trying to give you the most important thing that you can use and affect you. But if you'd like to deep dive, I encourage you back to read the second part of the hidden gems, which introduce a lot of hidden release notes of this JDK. And now let's talk about, like, new things are always coming. Old things has to go and has to say you are ready now to go, or you have gone forever. So let's see the most important thing that we have to take care of because we are migrating or like migrating the old APIs. So deprecation of local class constructors. Why? Because of the reason as in Java 19, the public constructor of the locale were marked as deprecated. So don't make use of it anymore. You should use the new static factory locale of. Why? I will give you an example. So for example, this code, it would like to compare some of the locale. So I will use the old deprecated locale here constructor to create an instance of the locale, and it should be also equal because this should be locale, and we have locale.Japanese, locale. This is the static instance. So they should be equal, but this is not the case. So if I create using the new of static factory and using the new the old deprecated constructors, and I would like just to make sure that they are equal to the same instance defined in the locale itself. So pre-created and loaded, so they should be equal. If you are comparing the constructor-based created variables locale, definitely, unfortunately, it will fail and it will say false because they are not the same instance. But if you are using the factory method comparison, and it will say true, and try this code in your G shell, and you will see the difference. This is why we are deprecating. We are not maintaining them because they have to be like value classes. They should be unmodifiable. Once you create it, it's like optional. It's like it should be treated also similar to wrapper classes. So they have the same behavior. So if you create it, they should be equally the same instance as those predefined locale. So this is one of the things that has been deprecated. So if you are using constructor, we will remove them in the future. No need to use them anymore. So another thing that, as ongoing to remove finalization and thread groups and these kind of error-prone methods in favor to enhance the threading module, those are deprecated for removal, and now we are continue. There is many methods has been removed from threads and thread group, and now as a part of JDK 19, they are marked for removal, and also sometimes they does nothing. So for example, thread group the destroy invocates will be ignored. If you are trying to invoke it, it will be ignored. It will be do nothing. Is destroyed, always will return false. Set daemon flag you can set, but this has no effect anymore. And get daemon, I'm just trying to maintain the code for you, and I give no functionality for you because you have not to rely on them anymore. Get daemon returns the value of the unset daemon flag, and also thread group that suspend, resume, and stop throws now unsupported operation in favor of there is nothing, but if using, I'm warning you because finally I will remove them from the thread group. So this is a continuation of degrading and decommissioning of these methods in JDK 19. So by reaching this, I would like to say thank you very much for your attendance. I would love to go back. Yeah, I will share it with you. And thank you very much for your attention, your time, and I hope you get benefit from this session. If you have any questions, you are welcome. And let me go back.
Thank you, Mohamed.
So here you can take it. No, it's my pleasure. So any questions do you have in your board?
Like you see, we don't have questions at this time of the channel, and we all thank you for the time, and we will see you in the next conference. Just 1 second, we have one question that you can answer.
Yeah.
And this is about what's the new features coming from Project Amber?
Okay. Which one? We have two features came to Project Amber. We have enhancement in the switch, which this one, and we have the record pattern, the new one. So the question for which feature?
I think that you just answer. He just asked about what is the new features, nothing else. And
Okay.
The last thing is that they ask about if they have access to the presentation. So I think that you can put again the last slide where you have links.
Yeah, indeed. I will put it on under my YouTube channel in the description.
Okay.
Is it okay, or there is somewhere here I can put it?
No, it's okay. So they can also see the recording session, and they will find it. So
okay, and I will put it also
on
the recording notes and comments, and you can find it out there. If not, just I will reshare it on my Twitter account and LinkedIn, everywhere, social media. Thank you very much.
Thank you very much. Thank you for being here. I will see you
and enjoy your time with the rest of the conference. There is a bunch of great speakers, so enjoy your time and see you next time.
Great. Thank you. Thank you all. See you.